Let us now look at parallel and perpendicular lines. So if two straight lines are parallel, then their gradient is the same. So if M1 and M2 are the gradients of two parallel lines, then we can say M1 is equal to M2. If two straight lines are perpendicular to each other, this means that the product of their gradient is -1. So if we have M1 and M2 as the gradient of the two perpendicular lines, then M1 multiplied by M2, that's going to be equal to -1. So I've said that for the parallel lines, if we have been given the gradient of two parallel lines as M1, we also have M2 as the gradient of two parallel lines. So we know that the gradient of two parallel lines is the same, so M1 is going to be equal to M2. Let us look at for two perpendicular lines. So for two perpendicular lines, so if we have these two gradients as M1 and M2, and we know that the products of two perpendicular lines, we know that the products of the gradients of two perpendicular lines is equal to -1. So this means that M1 multiplied by M2, that must be equal to -1. So that's the principle on parallel lines and perpendicular lines. Let us look at some of the examples. So example 1 reads, find the gradient of a straight line that is A, parallel, and B, perpendicular to the lines given by each of the following equations. So Roman numeral 1, I have y is equal to x plus 3 there. So for A, I'm supposed to calculate the gradient of the line which is parallel to this line, and for B, I'm supposed to calculate the gradient of the line which is perpendicular to this line. So I'll say A there. Since I know that the equation is y is equal to x plus 3, and we know that the gradient is the coefficient of x there, and the coefficient of x there, we have an invisible 1. So the gradient of that equation is 1. So for our perpendicular line, the gradient of our perpendicular line there is going to be 1. So that's going to be our gradient of our perpendicular line there, be equal to 1. So let us look at B. We are supposed to calculate the gradient of the parallel of the perpendicular line which is to that. We have calculated that the gradient of the parallel line will be 1 there. What about for a perpendicular line? So y is equal to x plus 3, and since there we have an invisible 1, which means our gradient 1 there, we can say that's going to be 1. So we can just represent this as M1 and M2 to just differentiate those. So our M1 is going to be equal to 1 there. So to calculate the gradient of a perpendicular line to this line, we're going to say M1 multiplied by M2 of that of a perpendicular line must be equal to negative 1. So m1, that's 1 multiplied by m2 is going to be equal to negative 1. So we're going to have m2 will be equal to negative 1. So our m2, our gradient 2 of this line will be equal to negative 1. That will be of a perpendicular line. Let us look at Roman numeral 2. So y is equal to negative, what's the equation there? Negative 3 over 7 x. So to find the gradient of the parallel line, we know that there our gradient is negative 3 over 7. So our m2 will be equal to negative 3 over 7 since parallel lines have the same gradient. What about b, of that of a perpendicular line? And since we know that our gradient 1 of this equation is negative 3 over 7, what about that of m2, which is that of a perpendicular line? We don't know, but we know that the product of m1 and that of m2 must give you negative 1. And since we have our gradient 1 there, which is negative 3 over 7 multiplied by m2 is equal to negative 1, that means we can calculate gradient 2. So that's going to be negative 3 over 7 m2 is equal to negative 1. We can transfer this side, we can just continue this side. So for us to find the value of m2 there, we're going to multiply both sides of the equation by, we're going to say negative 7 over 3 multiplied by negative 3 over 7 m2 is equal to negative 1. So we're going to multiply negative 7 over 3 on both sides of the equation. So multiplied by negative 3 over 7. And as you can see here, this and this is going to go, and this is going to go. So we're going to have our m2 is equal to, sorry, this is negative 7 over 3. This is supposed to be 3. So here we're going to have 7 over 3. So our gradient 2 of the perpendicular line is going to be 7 over 3. Let us look at Roman numeral 3 there, and for Roman numeral 3 we have 2x plus 5y is equal to 10. So we have 2x plus 5y plus 5y is equal to 10. Let me just compare that equation. Okay, it is correct. So A, we are supposed to calculate the gradient of the parallel line. So as you can see, this equation is not in our standard form. The standard form must be in this form, which is y is equal to mx plus c. So we're going to write down this equation in this form. So we're going to say 2x plus 5y is equal to 10 there, and we can transfer 2x to the other side of the equation. So we're going to have 5y is equal to negative 2x plus 10, and there to calculate y, you can divide by 5, divide by 5, divide by 5. So y is equal to negative 2 over 5x plus 10 divided by 5 that's 2. And since we know now that the gradient of this equation is our m1 is negative 2 over 5, so that means the gradient of the parallel line that is to this line, our m2 will be equal to negative 2 over 5. As simple as that. Let us now look at B, finding the gradient of a perpendicular line. So we know that our gradient, our m1, is equal to negative 2 over 5. And we know that our m1 multiplied by our m2 of that of a perpendicular line is supposed to be equal to negative 1. So our m1, we know that's negative 2 over 5. So multiplied by m2 will be equal to negative 1. So we're going to have negative 2 over 5 m2 is equal to negative 1. And to find m2 there, we're going to say multiplied by the reciprocal of that. We're going to have 5, the opposite of that, we're going to have negative 5 over 2, and this side we're going to have negative 5 over 2. You can cancel out there, so our m2 will be equal to negative 1 multiplied by negative 5, that's going to be 5, then 1 multiplied by 2, we're going to have 2. So the gradient of a perpendicular line is going to be 5 over 2. Let us look at Roman numeral 4. So I have 6x minus 2y plus 7. 6x minus 2y plus 7. We have 6x minus 2y plus 7 is equal to 0. And as you can see, this equation is not in our standard form, which is given as y is equal to mx plus c. So the first thing that we're supposed to do is to change this equation in the standard form. So for us to do that, we're going to say, so that's going to be our a for calculating the gradient of a parallel line. So 6x minus 2y plus 7 is equal to 0, and we are going to transfer 6x and 7 to the other side of the equation. So we're going to have negative 2y is equal to, when 6x goes to the other side of the equation, it's going to be negative 6x. Then when positive 7 goes to the other side of the equation, it's going to be negative 7 there. And from that we can say divide by negative 2, divide by negative 2, divide by negative 2. So y is equal to negative 6 divided by negative 2, that's going to be 3x. Then negative divided by negative, we're going to have positive 7 divided by 2. So that means the gradient there, our gradient 1 is equal to 3. That means that the gradient of a parallel line, which is m2, will be equal to 3. Let us now look at B, finding the gradient of a perpendicular line to this equation. So we know that our m1, that's 3, but we don't know our m2. But we know that our general form, we have m1 multiplied by m2 is equal to negative 1. m1 we know that's 3 multiplied by m2 is equal to -1. So we can say 3m2 is equal to -1. Finding our m2 there, we can say divide by 3. So our gradient 2 there is going to be -1/3. So that will be the gradient of the perpendicular line. Let us now look at example 2. Example 2a reads, find the equation of the straight line that passes through the point 4, 6 and is parallel to the line y is equal to 3x minus 8. So I've been told that we're supposed to find the equation of the straight line that passes through the point 4, 6. So this parallel line passes through 4/6 and it is parallel to this line, which is 3x minus 8. So our first thing that we are supposed to do, we are supposed to identify the gradient. So we know that the gradient of this equation, m is equal to 3. That means that it's going to be equal to this line, the line that we're supposed to calculate. So we can say y is equal to mx plus c, and we know that this is our x and this is our y, and we know that two parallel lines, their gradient is the same. That means the gradient of this line is also going to be 3. So we can say our y there, our y is 6, is equal to the gradient, we know that's 3, our x we know that's 4, plus c. So we can say 6 is equal to 3 multiplied by 4, that's 12, plus c there, and we can say 6, when 12 goes to the other side of the equation, we can say minus 12 is equal to c. 6 minus 12, that's -6, is equal to c. And since we know our y-intercept as -6, and we know that our gradient is 3, so we can say y is equal to mx plus c. So y is equal to, we know that the gradient is 3, so 3x, then we're going to have plus our y-intercept, we know that's -6. So y is equal to 3x minus 6. Since when we multiply positive and negative, we're going to have negative. So our equation of the straight line will be y is equals to 3x minus 6. So that's our first answer there of A. What about B? So B, we've been told find the equation of the straight line that is perpendicular to the line 3x minus 2y is equal to 4 and passes through the point -9, 5. So that is perpendicular to 3x minus 2y is equals to 4. So 3x 3, let me just check that, 3x, not 3y, sorry, (3x minus 2y is equal to 4 and passes through the points -9, 5, 5 there. So the first thing that we are supposed to do, we are supposed to find the gradient of this, and after finding the gradient of this, we are supposed to find the gradient of the line that is passing through -9, 5. So for us to calculate the gradient there, we are supposed to change this equation in the standard form. So we can say -2y is equal to -3x plus 4. And to find y there, we can say divide by -2, divide by -2, divide by -2. So y is equal to 3 over 2x minus 2. So you know that our gradient there is 3 divided by 2. And to find the gradient of the line that is passing through -9, 5, we know that these two lines are perpendicular to each other. That means that m1 multiplied by m2 multiplied by m2 that is going to be equal to -1. So our m1, we know that 3 divided by 2 multiplied by m2, so that's going to be m2 is equal to -1. And from that we can say, to calculate m2 there, we're going to say multiplied by 2 over 3 multiplied by 2 over 3. So our m2 will be equal to, can cancel out, it will be equal to -2 over 3. And since we know our gradient there, we can calculate c. So we know that our x, that's our y. So our y there, our y, that's 5, is equal to, our gradient there, it's -2 over 3, and our x, we know that's -9 plus c. So we're trying to calculate c there. So to simplify that we can say 3 here, 1, 3 here, we're going to have 3. So we can say 5 is equal to -2 multiplied by -3, that's going to be 6, plus c there. So we're going to have 5, when 6 goes to the other side, it's going to be -6 is equal to c. So we can say that our c there will be equal to 5 minus 6, that's -1. So let us just erase something here. So that we can write down our final answer. So since we know the y-intercept there, so we can say y is equal to mx plus 6 there. So y is equal to our gradient. We calculated our gradient as -2 divided by 3. So you can say -2 over 3x, and we have calculated our y-intercept as -1. So that's -1. So that's going to be the equation of the straight line that is passing through -9, 5.